everyone, and welcome to another episode of Organic Chemistry with Capadia. Today we begin our final unit, alcohols, ethers, and thiols. Oh my. So today we will be talking about the structure of these three groups and how to name them, or I guess they're categories of compound. All right, so we'll start with alcohols. Alcohols, as we know, are any hydrocarbon that has a hydroxyl group on them, an OH group. So we just add our OH group to our alkane here, and replace the hydrogen from the alkane with an OH group, and that gives us an alcohol. For the bond angles, the bond angle for alcohols is the CO bond is very similar to the CC bond, which is 109.5. It's a little bit smaller because of the lone pair on the oxygen. Lone pair. All right, so that is the structure of alcohols. Those are terrible lone pair. That is the structure of alcohols. So let's talk about naming. So with naming, we name them with IUPAC names, and then common names are also used very commonly. So first we'll talk about the IUPAC. It's the same way that we name alkenes and alkynes, but instead of changing the alkane name from an ane to an ene or an ine, we just change that ANE, or we don't change that ANE, we just change the E to an OL. So instead of an alkane, this would be an alkanol. Whenever we are numbering our carbon chain, the OH group obviously needs to be on the carbon chain, and then it should have the lowest number, takes precedence over all of the other groups, alkyl, aryl, and halo. The aryl is just the aromatic groups. The only aromatic group that we've talked about is benzene. So benzene is called a phenyl group, so it takes precedence over all of those things. If we have a cyclic alcohol, then the carbon that contains the OH group is going to always be carbon number 1, and then we begin naming from there. Alcohols can have cis-trans isomerization, and then everything else is the same. Common names are also used very frequently for alcohols, which you will know if you've ever bought rubbing alcohol from the store. The container says isopropyl alcohol, which is a common name. So the way in which we name these is we don't look at the chain, but what we do is we consider the alcohol itself to be the main chain, and then everything that's off of the alcohol is a branch. So it'll be the group that we are, that we name it after that group. So we only learned the alkyl groups going up to 4 carbons. So we had the methyl group, the ethyl group, the propyl and isopropyl, and then the 3 butyl groups, the 4 butyl groups, the butyl, and then isobutyl, tertbutyl, and secbutyl. Anything that is larger than that, we do not have to worry about doing common names for, because those groups are just super, super large and the names get complicated. And then they're just not that commonly found in nature, so it's not really that big of a deal. All right, so let's do some examples. So we'll look at some examples here, and we'll name them both in their IUPAC name and using their common names. All right, so we'll do the IUPAC name first. So here I have 1, 2, so that would be ethanol. There's no need to number this because it doesn't matter where I put it. It's always going to be 1, 2. There we go. It's always on the first one. So this would be ethane, gets changed to ethanol. If I'm naming this in the common way, then I just look at all the stuff that's attached to the OH group. So this is just a 2-carbon chain, so that's an ethyl group. So this is just ethyl alcohol. All right, next up we have our chain here. So we have 1, 2, 3. Name it the other way, it's still 1, 2, 3. So this would be 2, and since it's a 3-carbon chain, it'd be propane, so this becomes propanol. Then if I look at just the group that's attached to my alcohol, this group, is an isopropyl group. So this is an isopropyl group. Oh my goodness, my pen is now not working. So for the common name, if we just look at the group that's attached to the OH, this is an isopropyl group. So we would just call this isopropyl alcohol, which is the stuff that you buy in the store. All right, and then next up here we have, if we're going to name this, 1, 2, 3, 4. Obviously, we don't want to name it the other way. 1, 2, 3, 4. So this would be 2. And then this would be a butane is our chain. So this would be butanol. Then if we look at all the things that are attached here, so if we look at this group that's attached, it is it's 4 carbons. And so this group right here, I've got 2 coming off of one and 1 on the other with the carbon in the middle. So this is a sec-butyl group. So this would be sec-butyl alcohol. All right, let's do a couple more. Here we have another chain here. So we would have 1, 2, 3. Nope, just 1, 2. 1, 2, 3 here. I can also name it 1, 2, 3, 1, 2, 3. It doesn't matter. It's going to be on the second one. So I do have a group here. So this would be 2-methyl. And then my alcohol is on the second chain. So this would, or in the second carbon. So this would be 2. And then it's propane. So it would be propanol. So this would be 2-methyl, 2-propanol. This is 4 total carbons, which means that I can still name that group. So if I look at this group right here, I've got a carbon in the middle and 3 coming off of that. So that is a tert-butyl group. So this would be tert-butyl alcohol. Alcohol. All right. Next up, we have a cyclic group here. So this would just be, this is 1, 2, 3, 4, 5, 6. So this would be just, I don't have to name or put a number here because there's only one group on here and the alcohol is always number 1. So this would just be cyclo, and instead of hexane, it would be cyclohexanol. And then if I'm giving this a common name, this is a cyclohexyl group, which I know we haven't really talked a whole lot about the alkyl groups that are cyclic, but that's just all that they are. Instead of being cyclohexane, it's cyclohexyl. So this would just be cyclohexyl alcohol, which you can see as they start getting larger and larger, they start sounding weirder and weirder. All right, next up we have, let's see, 1, 2, 3. 1, 2, 3, 1, 2, 3. We always want to name the alcohol to be the lowest number here. I can't start up here because this would just be 1, 2, 3, and I don't want to do that. All right, so again, I've got a methyl group on the second carbon, so this would be 2-methyl, 1-propanol. And then if I'm giving it a common name, I can just look at this here, and this is going to be an isobutyl group, so this would be isobutyl alcohol. Isobutyl alcohol. All right, a few more alcohols just for funsies. Here we have some more things that are attached here. So if we look, we want to give the alcohol the lowest number. So obviously I'm going to start numbering from this side. So I go 1, 2, 3, 4, 5, 4, 5. Doesn't really matter where I put that. So this would be 4-methyl, 2, and this is 5 carbon, so it would be pentane. So this would be pentanol. And now we've gotten into the realm of it's too large to really name it with a common name. So now we just stick to your IUPAC names. All right, here we have another cyclic chain here. And then we have, whenever we have these wedges here, we know that we have cis-trans isomerization happening. So what I want to do before I tackle that is, first of all, figure out what we've got our naming situation here. So I always start with the alcohol, and then I'm just going to count to those smallest. So this is going to be a 2, 3, 4, 5, 6. It does not make sense to go the other way around. All right, so one of these wedges is solid, one of these wedges is not. So that means that they are on opposite sides. So that means trans. So this is going to be trans, and then 2-methyl, 2-methyl, put the methyl down here. And then this is cyclohexane with an OH, so it'd be cyclohexanol. 2-methyl cyclohexanol. Va-va-voom. All right, last one. Here, again, we have a cyclohexanol, and we have two more wedges. So this is a solid wedge and this is a solid wedge on here, which means that they're both facing the same direction. Both of them are coming out of the board. So here I would name this the same way. I would start with the alcohol and then I would give that isopropyl group this second name. So because these are both solid wedges, this would be cis 2-isopropyl, and then this would be cyclohexanol. Perfecto. All right, we talked about this previously at the very, very beginning when we talked about functional groups, but alcohols do have classifications. So just as a refresher, primary alcohols have only, if this is our carbon containing our alcohol, it's only attached to one other carbon. Secondary alcohols have carbons that have a second carbon attached. So here is our carbon, and there is 2 carbons attached, so it's secondary. And then tertiary is obviously when you have 3 things attached. So we've got 3 things here, so we should probably draw our OH group. So this is our carbon, and we've got 1, 2, 3 things attached to that, so that makes it tertiary. All right. And then the very last thing with alcohols are when you have multiple OH groups. We name them just like we did with alkenes that had multiple OH groups. I'm sorry, not multiple OH groups, multiple double bonds. So we change the ending to the appropriate prefix representing the number of alcohols, and then we add all on the end. So if there are 2 alcohols, then we add diol to the end of the name of the alkene. If there's 3, then it's triol, and that's really all that we've got. When you write the alkene, you do not drop the E on the end, so it's just like, it'll just be, well, let's do an example. And then just like before, we use numbers to designate the placements of OH groups right before we name the chain. And then a special category of multiple OH hydrocarbons is glycols. That's when the OH group is attached to adjacent carbons. So when the carbons are right next to each other. Okay, so let's take a look at some examples here. All right, so here we have 2 OH groups. I have carbon 1, carbon 2. There's not really anything else or anywhere else to put that. So this would be 1, 2, and then there's only 2 here. So this would be ethane. And then because they're 2 alcohol groups or 2 hydroxyl groups, that would be diol, ethane diol. So this is what we mean when we say adjacent carbons. So carbon 1 and carbon 2 both have OH groups on them. So this is a glycol. This is actually called ethylene glycol. Ethylene glycol. And we'll come back, and I think I spelled that wrong. Yeah, glycol. There we go. We'll come back to that in a little while. Or in the next section. All right, next up here, we have 2 alcohols here, so I can name this 1, 2, and 3, or I can name it 1, 2, and 3. I want to give the lowest number possible, so we'll do this. So this is going to be 1, 2, and then this is propane, so this will be propane diol. And then here again, we can see that the hydroxyl groups are on carbons 1 and 2, so those are adjacent. If the hydroxyl group had been over here, they would not be adjacent, and that would not be a glycol. But since these are adjacent, this is a glycol, and this is called propylene glycol. All right, so let's do a couple more. All right, so here we have a triol, because we've got 3 groups attached. So we have 1, 2, 3 here. So this would just be 1, 2, 3, propane, and then it would be triol. This is not a glycol, but does actually have its own cool name. This is glycerol or glycerin. It is used in a bunch of different food type products and medication as well. All right, and then lastly, we have this right here. This is 2 groups, 2 hydroxyl groups here, and we've got this cyclohexane. So we would name this, and it doesn't really matter where we start naming because it's going to be the same regardless of where we start. So this is 1, 2, 3, 4. So this would be, and we can see here that we've got one coming out of the board, one going into the board. So those are opposite. So this is actually trans. So this would be trans 1, 4, cyclohexane diol. Okay, all right, so that is alcohols. All right, so next up we have ethers. All right, so an ether is basically just an R group with an R group connected by an O. R-O-R, roar. Because there's no functional group, like it doesn't matter what this chain is or what this chain is, it's not a specific functional group, it's just an O in the middle. This is the bond on the oxygen between the two carbons is a little bit larger just because of the way that the structure is and the lone pair, and that there's not any hydrogen there either. So it's a little bit bigger than the carbon-carbon bond angle. All right, for naming, we are only going to name the low weight ethers. The higher weight ethers have really complex IUPAC names that we're not going to get into. So we're just going to stick with smaller things. We are going to name aliphatic ethers and then cyclic ethers. So if you remember, aliphatic ethers are just those that are in a straight chain. So whenever we're naming straight chains, we just look at the common names. And so the way that we do that is we look at what's attached to the oxygen. So there's going to be an alkyl group on one side and an alkyl group on the other side. So I just name the two alkyl groups and add ether at the end. When I name them, I do put them in the correct order, in the correct alphabetical order. All right. And then we have cyclic ethers. So the cyclic ethers have these special names. We are not going to get into the whole dynamics of these cyclic ethers, but basically if we have a 3-membered ring with an oxygen in the middle, we call that an epoxide. So it would look like this. If we have a 4-membered ring with an oxygen in the middle, then it would just look like this. Oh, here. So it's just like cyclobutane, but it's got the O is a part of the ring instead of being outside of the ring. And then we have this 5-membered ring that is called a furan. And so this ring right here looks like this, where you've got this O in the middle, and then we've got a double bond here and a double bond here, and then there's some lone pair here. This is actually an aromatic ring. These two double bonds can alternate, and so we end up with a with an aromatic. So it has the properties very similar to what benzene has. And then we have the last one, which is a pyran, which is a 6-membered ring with 2 double bonds, is our final common one that we have. So this would just be an O here. So it kind of sort of looks like benzene, but it is not an aromatic because there's no, the bonds can't alternate here like they can up here. So those lone pair on those oxygen are able to provide like that third kind of oscillation that occurs. But here we cannot have that, so this is not an aromatic compound. All right, so let's name some things. Okay, so whenever we're naming, we really just name what's attached. So here I have a methyl group, and then here I have attached an ethyl group. So I put them in alphabetical order, so this would just be ethyl methyl ether. These are fun sounding names, and it's all just one word. Ethyl methyl ether. No, ethyl methyl is one word, and then the ether is the second word. All right, if we look here, we have on one side, we have an ethyl group. And then on the other side, we also have an ethyl group. And so here, this is just going, it's not ethyl-ethyl ether, it's 2 ethyls, so it is diethyl ether. Diethyl ether. Oops, I wrote that wrong, didn't I? Diether ether, diethyl ether. There we go. All right, so next up here, we have this group here on the left. So this is going to be a sec-butyl group. And then over here on this side, I have an isopropyl group. So I'm just going to put these in alphabetical order. So sec is a prefix, so I actually look at the B for butyl. Isopropyl is part of the word, so I look at the I here. So this is going to be sec-butyl isopropyl ether. Sec-butyl isopropyl ether. All right, here I have a phenyl group. And then here I have another phenyl group. So this is just going to be diphenyl ether. Diphenyl ether. There we go. We'll do a couple more. And by a couple, I mean two more. So here we have this group right here. So this is going to be an isobutyl group. Isobutyl. And then over here we have 1, 2, 3. So this is a propyl group. All right. And so we're naming. Iso is part of the prefix, and then propyl. So this would just be isobutyl propyl ether. And then the last one that we'll look at here, this is a cyclohexyl group. We just talked about this when we talked about alcohols. Anytime you have a group that's got a cyclic, it's like if it's cyclohexane, it's just cyclohexyl. If it's cyclopropane, it's just cyclopropyl. So this is cyclohexyl. Oh, I should probably name the other one before I get carried away here. This other side, oh no, this is what I wanted to do. I wanted to write cyclohexyl. And then over here, this is just a methyl group. So alphabetically, this would be cyclohexyl methyl ether. Excelente. All right, so last but not least, we have thiols. So thiols are basically just alcohols, except for instead of having an O, you have an S. Oxygen and sulfur are both in the same group, and so they behave in the same way. The main difference between these two is that the oxygen and the hydrogen is able to form hydrogen bonds, whereas this is not able to form hydrogen bonds. This is just dipole-dipole interactions when we look at intermolecular forces. We'll talk more about this when we talk about the properties of these, but that's really the only difference here. This bond angle is even smaller than the alcohol bond angle because the sulfur is so large, and because of the lone pair on the sulfur as well. Thiols are named as such, just fun facts, trivia for you, for the Greek word for sulfur, which is thion. I practiced saying this and then I screwed it up anyway. Thion. I'm not going to even try anymore. There's the word. Common names are called, for thiols, are called mercaptan, which sounds really weird, but it's for mercury capturing. It's because of the way that sulfur reacts with mercury and is able to form mercurious compounds. So that's why it's called mercaptan. I think it's super fun. It sounds like somebody who is a captain of a ship that's looking for mermaids, but that might just be me. Okay, so for nomenclature, this is similar to alcohols where we can name them both in the IUPAC way and the common name. And it's exactly the same as for alcohols as well, except for instead of changing the alkane ending to OL, we just add the word thiol on the end, but we don't remove the E. So it's just an alkane thiol is what it would be. It's very messy looking, but you know, it is what it is. And then for common names, it's the same thing as alcohols. We just use the alkyl group that's attached, but instead of saying like ethyl alcohol, we would just say ethyl mercaptan. All right, so let us name some of these things here. So we'll start here with 1, 2. So this is ethyl. So this would be ethane thiol. And then the common name, I would just look at what's attached here. This is an ethyl group. So this would be ethyl mercaptan. All right, and then we would do 1, 2, 3. All right, so this would be 2, and this is 3, so this would be propane thiol. All right, and then we look at the group that it's attached to. This is an isopropyl group. So this is just isopropyl mercaptan. It's not mercaptan, mercaptan. All right, and then let's look at the next guy here. We're going to name with the thiol group first. So this would be 4-methyl 2, and then this would be pentane thiol. And this is 2 large 5 carbons. It's actually 6 carbons on here. So we don't really know how to name this with an alkyl group, so we'll just stick with the IUPAC name. All right, here we have more of the same. We have some cyclohexane. There's only one thing on here, so this would just be cyclohexane thiol. Cyclohexane thiol. You could also give this a common name because this is a cyclohexyl group, so this would just be cyclohexyl mercaptan. All right, and then here we have cyclopentane, and we've got the arrows here, so we'll start naming with the thiol. We go 1, 2, 3, or we can go 1, 2, 3, 4, so this is good. So this is going into the board, this is going out of the board, they're opposites, so this is going to be trans. So this will be trans 2, what is this, methyl? Nope, just kidding, trans 3-methyl. And then this would be cyclopentane thiol. Again, this is too complex for an alkyl group, so we'll just stick with the IUPAC name. All right, lastly, we have a cyclobutane here. This is going out of the board, and this is going out of the board, so this is again trans. So this would be trans 2 isopropyl. This would be cyclobutane thiol. All right, so that is the naming of alcohols, ethers, and thiols. This has been another episode of Organic Chemistry with Wikipedia. Until next time, keep on chemin'. So, this has been another episode of Organic Chemistry with Wikipedia. I hope you learned something, and until next time, keep on chemin'.